Okay, so we're going to start going back into 1.3 and look at graphing polynomial functions. And to do this, we're going to use our previous knowledge of zeros, which we can also call our x-intercepts, as well as y-intercepts, and kind of getting our new found knowledge on the end behavior of a function, which is determined by the degree of the polynomial, as well as the leading coefficient. And we're going to start taking all that stuff and combining it to get a graph. Okay, so that's what we're going to be working on. Okay, so let's just kind of refresh our memory on zeros. If I give you a polynomial function x plus 2 times x minus 3 times x plus 7, what are the zeros? So we have our zeros at x is negative 2, x is positive 3, and x is negative 7. So if we started building a graph, we can take our grid, we can put in our zeros at negative 2, positive 3, and negative 7. And now we're starting to build towards our graph. Okay, so if we look at our polynomial function f of x, tell me other things that you know about our function f of x. What are some characteristics that if we were to examine our function closely, what can you tell me about that function? So if we took our brackets and expanded those out, we would see that we are going to have an x cubed term. So we can see that our function is going to be an odd function. Specifically, it's going to be a cubic. Okay, what else can we tell about that function? Specifically, the leading term. Okay, we know it's going to be a cubed. What do we know about the leading term? What else do we know about it? Okay, so if we multiply this out, because we have a positive term in front of each of the x's, we're going to get a positive leading coefficient. Okay, so how can we take the knowledge of end behavior that we gained the other day and apply it to this question? What does having it be an odd degree polynomial, how do we know it's going to be a cubic, and a positive leading coefficient, how can we combine those into some useful information that we know or we can tell about this graph? So we can put those two pieces of information together and tell us that this graph that is going to go from quadrant 3 to quadrant 1. Okay, so we're looking at that. So, all right, well, it has to go off this way and has to finish going off that way. We can get our graph by connecting the dots. Okay, now this is going to give us an approximation of the graph. If we expanded out these brackets, we could easily find the y-intercept. Okay, if we wanted to plug in other points, we could figure out where what some other points are, but we know already that we have the point negative 7, 0, we have the point negative 2, 0, we have the point 3, 0. We could find the y-intercept if we need. We have a sketch of that graph. So our first example was pretty straightforward. I'm going to give you a second function, and we're going to look at that one. So our example number 2, if we had a function that looks, say, x plus 2, but our second term is going to be an x minus 3 squared. Okay. So what are some properties, what are some characteristics of this polynomial function? Okay, and if I want to put it maybe a form that you might be more used to, just going to expand it out just a little bit. So what are some things we know about the characteristics of this polynomial? Yes. What are our zeros? and x equals positive 3. Now, what is different about our 0, x equals positive 3? There's two of them. This one happens twice. Okay, so at 2 points, we're going to get a 0 of positive 3, and that's going to come down here. Okay, so that's obvious. Like, it's pretty obvious that from our squared, we're going to get this 0 twice. Okay, so it's kind of intuitive that something different is happening at this 0 of 3 than at the negative 2, just because there's a square here and it's happening twice. But what we're going to do is get our grid, and we'll start trying to figure out what our graph's going to look like. We have a 0 at negative 2, and we have a 0 at positive 3. What else can you tell me about this function? What are some more characteristics of it? Okay, so we have positive coefficients. So what's that going to give us? Yeah, so all of our coefficients are positive, which means we're going to have a positive leading coefficient. And what is the degree of our polynomial? Okay, this one's going to be another cubic. And if we combine those two things together, positive leading coefficient and it being a cubic, what can we tell? So we can figure out our end behavior. Our graph is going to run from quadrant 3 over to quadrant 1. Okay, so if we look at that, it's got to start going off this way and finish going off that way. So if we start to try and graph this, we look at our zeros, and we say, all right, we have to finish it or start in quadrant 3. It's going to go up. It's going to go through negative 2. Then we're going to come back down, hit our 0 at positive 3. Because we're hitting it twice, it's going to act like a quadratic around that. And it's going to just come down, touch it once at 3, 0, and then take off into quadrant 1, gone forever. So what this will come to is in your textbook, you will see something, or you read something that looks like this. It'll say, if a polynomial function polynomial function has a factor x minus a. So in the example we just did, we had a factor of x minus 3 that is repeated n times. So if we have a factor x minus a that is repeated n times, and what that'll look like if you have, say, x minus a to the power n. So it has is repeated n times, so x minus a to the power n. What we can say then, x equal a is a 0 of our polynomial function. I'm just going to call it f of x. So of our function f of x of order n. Okay, so here's some technical language for you that you'll see in your textbook. Okay, just so we have it written down here, order is going to kind of refer to how it touches, how our function f of x touches or crosses the x-axis. And what we'll say here is that if the order is odd, that's going to mean our function switches signs across the 0. And we'll say if the order is even, if the order of even, our function, the sign remains the same. Okay, so just visually looking at that, if our 0 here on the left is an odd order, the function's going to change sign, which means it's going to go from negative to positive or positive to negative. If our function, or if our 0 is an even, as even order, it's going to stay positive or it's going to stay negative. Okay, so that's just kind of visualizing what this technical language is saying for us. So we're going to make a chart. First column of our chart says a factor of our polynomial, factor of f of x. So each one of the things in this chart could be a factor of a bigger polynomial. The second column is going to say the order of that factor. And our third column, we're going to talk about how our function acts about that 0. So if we had a factor that looked like, say, x plus 4, what is the order of that factor? Okay, to find the order, look for the exponent of that factor. So what is the order of x plus 4? So of order 1. Okay, how is our function going to behave as it crosses at negative 4? It's going to switch signs. It's going to act like a straight line. And if we drew just a little sketch, we're going to have a 0 at negative 4. And our graph could either be going that way through it, or it could be coming down. It's going to act like a straight line, and it's going to change signs. Okay? If we look at a polynomial, or if we have a factor, say x minus 3 squared, like the one that we had in our example before, what's the order of that one? It's of order 2. And this one's going to act like a quadratic. It's going to act like a quadratic around that 0. So if we had a little axis, we put a 0 at positive 3. We know our function is going to come down and go back up, or it could come up and then go back down. Okay, and how we'll determine what it does is in relation to the other zeros of that function and the end behavior. Okay, so our next one, we're just going to finish this up really quick. Say we have x minus 2 cubed. What's the order of that factor? It's of order 3, and that's going to cause our function to act like a cubic. So if we have our graph, we have a 0 at positive 2. And around that, our function is going to act like a cubic, so it's going to come up and go like that. Or if it was coming down, it's going to go like that. Okay, if we did something of degree 4, we know something of degree 4 looks like a quadratic, so it's going to have that same type of shape. And if we had something of degree 5, well, a 5th degree looks like a cubic, so it's going to have that very similar type shape as well. Now we can start taking these and pulling them all together to do a bigger example. And the example we'll look at is if we had the function okay. So if we're trying to get a sketch of the function x minus 1 cubed times x plus 5 times x minus 8, okay, trying to get a sketch of that, just starting off and sketching would be very, very difficult. So let's break that up first. First thing we want to do, let's state our zeros. So what zeros are we going to get from this function? 1, -5, and 8. So our zeros, and just so you can work backwards, I would say you're going to have a 0 of 1, and in brackets beside it put order 3. And our second one we're going to have is -5, order 1, and +8, order 1. If you're working backwards and it doesn't state the order, assume it's 1. Okay, if it's any, it'll tell you if it's anything else. So if we look at that, we have zeros at -5, at +1, and at +8. What else can you tell me about this function? What's going to be positive? Okay, so all of our terms are positive, so we're going to have a positive leading coefficient. What else can you tell me about the graph? Is it going to be cubic? If we expanded this all out, yeah, quintic, it's going to have degree 5. Putting those together, what can you tell me about the end behavior for that function? So it's a positive leading coefficient, has degree 5, so it's going to go from 3 to 1. Okay, so if I'm putting all that together, I know that my graph has to kind of start over here and end going up this way. It's going to cross -5 like a straight line, so it's going to go up. It's going to cross this guy at a straight line. It's going to come down. It crosses 1 like it's our 0 at 1 is order 3, so it's going to cross it like a cubic. So it's going to come down, act like a cubic right in that around that 0, and it's going to come up through +8 of order 1, so it's going to cross it like a straight line, and it's going to go off. So that's how we can put all those together to get a sketch for that polynomial function.